So in this video we're going to look at solving trigonometric equations with coefficients in the argument. I'm just going to look at another example or two in here, and I'm going to move through them a little bit more quickly. So step one is we're going to identify the domain. Notice the domain here is x is between 0 and 2 pi. So x is on the interval from 0 to 2 pi, inclusive, square brackets inclusive. But 2x is the argument in my equation, so we're going to just look at the domain for 2x. 2x will be between 0 and 4 pi. Notice that's two full circles. 4 pi, two full circles. 2 pi is 360 degrees. 2 pi radians, 360 degrees. One full circle. 4 pi radians, 720 degrees. Two full circles. Okay. The other thing here is cosine of 2x here is positive. That's a positive root 3 over 2. And that happens if and only if 2x is in quadrants. Well, remember, cosine is positive in first and fourth quadrant. So 2x is in quadrant 1 or 4. Okay, so that's the first thing. Identify the domain and the quadrant. The next thing I'm going to identify is the reference angle. So cosine of 2x. Cosine of 2x is root 3 over 2, which means that cosine of the reference angle is the absolute value of root 3 over 2, which is also just root 3 over 2. You should know the reference angle at this stage. Cosine of 30 degrees is root 3 over 2. The reference angle here will be 30 degrees. If you're unsure about that, just type in cosine inverse of root 3 over 2 into your calculator. Cosine inverse square root 3 divided by 2, 30 degrees. Okay, that's my reference angle. Now I'm ready to draw. So I'm going to draw, sketch my curves. 2x, well, 2x, that's two full circles. And so I'm going to look first of all at my reference angle and my quadrant. I'm in quadrant 1 and 4, reference angle 30 degrees. There's quadrant 1, reference angle 30. There's quadrant 4, reference angle 30 degrees. And I'm going to look at two full circles for 2x. So there's my first, go around here and change the color. There's the first time in quadrant 1 we hit that. And that's between 0 and 4 pi. So the first time, 30 degrees, pi over 6. But maybe I'll change to radians at the end. Maybe we'll just deal with degrees for the moment in this one. So I'm going to say 2x could be 30 degrees for one, going around the first full circle. Going around the second full circle, that'll be 360 plus 30. 360 plus 30 is 390 degrees. Okay, if I go around any further, I'll go beyond 4 pi. So changing that into radians, 30 degrees is pi over 6 radians, or 390 is, I think, 13 pi over 6 radians. Okay, in this one going around here, remember what we'll find here is 2x, not x just yet. The first time we'll hit that angle in the first circle we're going around is 30 degrees short of 360, which would be 330 degrees. Whoop. Write that again. 330 degrees. Or going around, through another full circle, that's 30 degrees short of 720, or 690 degrees. Okay. So again, changing those into radians, that would be 11 pi over 6 radians, or 23 pi over 6 radians. Okay, so we have our solutions for 2x. There are 4 of them. I'm going to write them in a set in ascending order. Pi over 6, 11 pi over 6, 13 pi over 6, and 23 pi over 6. But again, we've solved there for 2x. Anytime I'm trying to solve an equation, I'm trying to solve for x. So x, dividing everything by 2, which is the same as multiplying by a half. Top by 1, bottom by 2, pi over 12, 11 pi over 12, 13 pi over 12, 23 pi over 12. And there's my answers. Okay, how do I check it? You know, take your calculator, make sure you're in radian mode. So in my calculator, there's shift setup, number 2 for angle, number 2 for radian, and I'll type in cosine of 2 times, say, pi over 12. You type it in and you get root 3 over 2. And check for each of them. Okay, so do check. All right, look at one more example. So again, just, you know, it's the same 3 steps over and over again, and make sure you can follow them. In this case, we're asked to solve. So I'm trying to find what pi is. I'm given a kind of a trickier domain here. That's a typo. That should say theta. So tan of theta over 2 is equal to -1. Theta is between 360 and 720. Identify the domain. Theta is on the interval from 360 to 720 degrees inclusive, which means theta over 2, well, actually we're dividing by 2 here, will be on the interval from 180 degrees to 360 degrees. Okay, also tan of theta over 2 is negative here, it's a -1, and that can only happen if theta over 2 is in. Okay, well, let's take our memory tool up here. Tan is positive in quadrants 1 and 4, so tan is quadrants 1 and 3, tan is negative in quadrants 2 and 4. Okay. Next thing is the reference angle. And tan of the angle theta over 2 is equal to -1. That's given. That means tan of the reference angle is equal to the absolute value of -1, which is just 1. And again, if you know your special angles, you should know your reference angle. If you don't, you just type in tan inverse of 1, hit equals, and it's pi over 4. Make sure you're in, it's not pi over 4 because we're dealing with degree mode. It's 45 degrees. Dealing with degrees, of course, because the domain is given in degrees. Okay, so we're looking for, what are we looking for? We're looking for angles between 180 and 360 with a reference angle of 45 degrees. So I'm going to sketch. We're in quadrants, what did we say? We're in quadrants, tan is negative in quadrants 2 and 4. So I'm going to sketch in quadrant 2, reference angle 45 degrees. In quadrant 4, reference angle 45 degrees. In quadrants 2 and quadrants 4. Okay, now theta over 2 has to be between 180 and 360. Now, 180 degrees, if I go around, there's 0 degrees, 90 degrees, 180, 270, and 360. Well, this angle here in quadrant 2 is not between 180 and 360, so we can kind of discount that. That is not going to be in there, so we can get rid of that. So my angle in this case is going to be in here. Okay, 45 degrees. Theta over 2 is equal to 360 minus 45. That's 315 degrees. Okay, if I was to solve this one up here, it's 45 degrees, it's in the second quadrant, so the 180 minus 45, this would give me theta over 2 equal to 135 degrees. But again, that is not part of my interval, so I can discount it. If I was to find theta, I'd find 270, not part of my interval. So theta over 2 is 315. Doubling, we get theta is equal to 630 degrees. How do I check it? Well, is it part of my domain? Yes, it is. Is tan of half of that equal to -1? Well, how do I find that? Well, you type it into your calculator. Make sure you're in degree mode. You type in tan of 630 over 2, and it's -1. And that's my answer. Notice if I'd work this, I'd get tan of 270, 270, tan of 270 over 2. You put into your calculator is equal to -1. However, 270 is not part of my domain for this problem. So one single solution here in this case. Okay, solving trigonometric equations with coefficients in the argument. Practice them. Practice, practice, practice.